Zeekr Gold Brick Battery, 800V Ultra-Fast Charge Lithium Iron Phosphate, charge 15 minutes, drive 500 kilometers. Let's first briefly experience the performance of this gold brick battery. Charging for 15 minutes, increasing range by over 500 kilometers. Volume utilization rate of 83.7%, the highest in the world. 14.8% reduction in cost per kilowatt hour. 40% increase in production efficiency. Maximum charging rate 4C. Maximum discharge rate 16C. At present, the mainstream power batteries are divided into two categories: lithium iron phosphate batteries and ternary lithium batteries. The former has low production costs, high safety, long service life, and is very suitable for large-scale promotion and use. However, compared to ternary lithium batteries, lithium iron phosphate batteries have a lower energy density and relatively slower charging speed. Everyone should know that slow charging speed is a major pain point for lithium iron phosphate batteries. Even in the fast charging range of 30% to 80%, ordinary lithium iron phosphate batteries still require more than 30 minutes of charging time, which is approximately a 2C charging rate. However, the Zeekr Gold Brick battery adopts an 800V architecture, with a stacked multi-pole ear structure and dual rivet pole guide design for the electrodes, as well as lithium-ion full acceleration technology. The maximum charging rate reaches 4.5 C, and the maximum charging power can reach 500 kilowatts. In the fast charging range of 10% to 80%, it can achieve a 15-minute charging time and increase the range by more than 500 kilometers. What is this concept? Currently, 2C and 3C fast charging are the mainstream levels, 6C is the ceiling, and only a few ternary lithium batteries can achieve it, while the Zeekr lithium iron phosphate brick battery can achieve 4.5 C. Even compared to many ternary lithium batteries, the charging speed is far ahead, and lithium iron phosphate batteries have officially entered the era of overcharging. The Xiaopeng G9 and Xiaopeng G6, both on the 800V platform, have achieved ranges of 399 kilometers and 324.8 kilometers respectively after 15 minutes of fast charging. The long-range max version of the Smart World S7 has a range of 352.5 kilometers, which is still a gap compared to the Zeekr 007 equipped with a gold brick battery. Zeekr stated that the Brick's battery has an ultra-fast charging capacity of increasing 500 kilometers in 15 minutes, and even at low temperatures of -10 degrees Celsius, the charging speed of the Brick's battery has increased by 25%. In terms of discharge rate, the highest 3-second pulse discharge rate of gold brick batteries can also reach 16C, without limiting the motor power output at all. The Zeekr 007, equipped with a gold brick battery, can easily achieve 0 to 100 acceleration performance in 3 seconds. Under the same system, the battery capacity of gold brick batteries is 26% higher than that of traditional lithium iron phosphate batteries, breaking the previous limitation that large-capacity lithium iron phosphate batteries can only be installed in large SUVs and MPVs. The reason why brick batteries can achieve this is not because the electrode increases the energy density of the cell, but because it improves the volume utilization of the cell compartment. Taking the well-known 4680 battery in the industry as an example, its volume utilization rate is only 63%, while the volume utilization rate of ordinary lithium iron phosphate batteries is 66%. Even the ceiling of ternary lithium batteries has just exceeded 72%. The utilization rate of Brick's batteries has reached 83.7%, which is currently the highest volume utilization rate of power batteries produced in the world. The Brick's battery adopts a compact sandwich structure consisting only of the battery cell, top cover, and bottom plate. The Zeekr vertically adjusts the square step compartment, resulting in a 7.6% increase in volume utilization. Aviation-grade ultra-thin thermal barrier materials are used between the battery cells, transforming the originally thick partitions into thin screens and increasing volume utilization by 6%. At the bottom of the battery, the integrated liquid cooling tray is used instead of the traditional water pipe structure, which further increases the volume utilization rate by 8.5%. Not only that, compared to traditional designs, the total length of the wire used in the gold brick battery has been shortened by 157 meters, the core components have been reduced by 35%, and ultimately the battery quality and energy density have been increased by more than 10%, achieving a breakthrough in storage technology for lithium iron phosphate batteries. Of course, the data that I think everyone is most concerned about here is how much energy density the battery system has achieved under such a high volume utilization rate. Although it has not been officially announced, according to engineers, the energy density of the battery cells exceeds 250 Wh/kg. I also saw the nameplate parameters of the finished battery pack in the factory: not allowed to take photos, capacity 75.6 kilowatts H, mass 589 kilograms, rated voltage 610 V. Calculate the energy density of the entire package to be around 128 Wh/kg. The energy density of the first-generation blade battery currently used by BYD is 140-150 Wh/kg. The energy density of the second-generation blade battery can reach 180 Wh/kg, and the energy density of the Ningda-era Qilin battery, ternary lithium cell, is 255 Wh/kg. It can be seen that although the volume utilization rate of Zeekr gold brick batteries is high, there is still significant room for improvement in the energy density of the system. The Zeekr gold brick battery, like BYD's blade battery, uses a blade iron phosphate lithium battery cell, but the difference is that it uses a short blade battery cell, which looks only about 500 mm, and starts from an 800V platform. However, most of BYD's batteries are long blade cells, with cell lengths ranging from 600 to 2500 mm, mainly at 400V. From the arrangement of the battery pack, it can also be seen that BYD can fill the width space of the battery pack with just one long knife battery cell, while the Zeekr gold brick battery is composed of two short knife battery cells spliced together. The outer packaging of the battery cell is not the traditional blue insulation film, but the gold high-voltage resistant insulation film. Not only does it rename the gold brick battery, but this material can also withstand 4000V DC high voltage, with a 27% increase in high voltage resistance and less prone to short circuits. As for which one is better, short knife battery cells and long knife battery cells, I think each has its own advantages. Long knife can reduce the number of battery cells and is more conducive to thermal management. But short blades are more suitable for fast charging at 800V and above 4C, because the shape of the long blade battery cell is too long, and the charging current needs to pass through a long path. The charging time is long, and if the charging and discharging current is too large, it is more prone to thermal runaway. Moreover, chassis deformation is more likely to cause large-scale battery short circuits, leading to spontaneous combustion. Short blade battery cells can reduce these risks. In order to pursue higher standards of battery safety, Zeekr upgraded the 6 safety measures of the gold brick battery pole cell battery pack to 8 items, achieving real-time protection of the battery pack's overall safety. The first one is the overpressure needle puncture test, which upgrades the traditional needle puncture test by applying a compression force of 1.5 times the national standard to the fully charged gold brick battery cells, so that the compression deformation of the battery cells can reach more than 30% after standing for 1 hour. Use a 5mm steel needle to pierce through the point with the highest degree of bending, causing the battery cell to short circuit directly. The entire process can achieve no fire or explosion of the battery cell. The second one is the external fire test. In the battery pack fire laboratory of the National Motor Vehicle Product Quality Inspection and Testing Center, the experimenters tested the gold brick battery by directly burning it on an oil pan. The flame temperature in contact with the battery pack was above 700 degrees Celsius, and the continuous fire lasted for 240 seconds, exceeding the national standard test time of 130 seconds. The battery pack still did not catch fire or explode. The third one is the 6 extreme working condition test, which means that the same gold brick battery is continuously subjected to 6 extreme tests such as immersion, fire, freezing, towing, rolling, and high drop. However, even so, the gold brick battery still does not ignite or explode. Soak in 10% saline solution for 48 hours. 1000 degrees Celsius flame roasting for 130 seconds. -45 degrees Celsius extreme cold 8-hour test. Towing on rough roads for 3 kilometers. 22-ton roller compaction. Falling from a height of 10 meters. Compared to ternary lithium batteries, lithium iron phosphate batteries have inherent safety advantages, and blade lithium iron phosphate is structurally more conducive to safety protection. In terms of the existing technological system, the Zeekr gold brick battery is clearly at the forefront, with fast charging and cost reduction being its biggest advantages. Although there are still some shortcomings, it should be able to improve quickly through 1 to 2 years of market application and technological iteration. Anyway, it's a good start for Zeekr. After all, they have mastered a core technology. It is said that this battery will first be installed on the standard range version of the Geely K7, and the new car is also about to start a test drive. The actual range performance of the battery will soon be determined.